Hello guys, Anthony Silva here. Welcome back to my next video for the my LeetCode 150 walkthrough. So today we're going to go through the top K frequent elements question. We're still on the arrays and hashing question set here. So we're just going to be moving on with that same topic here. So I've actually solved this problem before. Um, and shortly after I solved it, I realized that there was actually a couple other solutions that can be implemented at the same time as well. So I will try to go over these with you today. But but probably not going to go over all of them just for the sake of time. But I will definitely introduce a few solutions that might seem to be that might come up at first glance as you read the problem statements. But without further ado, let's give this a try. So, given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Alright, so example 1, looks like we got 3 1s, 2 2s, 1 3. K is equal to 2, so you want to output the first the two most frequent elements, which are 1 and 2, and that's going to be returned in the list. Okay, and then we have a 1 element array. K is going to be equal to 1. Alright, and then output simply 1. Again, still going to be a list, even though it's just going to be 1 element. Okay, looks like there could be at least up to 10,000 elements in our nums array. Numbers can be significantly small or significantly large. Not too large, if it's K is in the range of 1 to the number of unique elements in the array and a closed-end array. So K could potentially, and then it is guaranteed that the answer is unique. So we're not to worry about there being multiple answers. Saying if we want to say, for example, if we are asked to return the top 2 elements, but there are, for example, like 3 1s, 2 2s, and 2 3s, the answer could be 1 and 2 or 1 and 3. We don't have to worry about. Looks like we don't have to worry about there being multiple answers here. So that's pretty good. Good thing to point out is that the algorithm's time complexity must be better than the O n log n time complexity, where n is the array size. All right. So the solution is that I came up with actually does run in linear time complexity. So yes, it is very possible to solve this problem with linear time complexity of O of n time complexity. However, we're just going to stick. So however, I'm just going to stick with a couple other solutions first, just to give the idea of how this problem may be approached. All right. So as with many array problems, we cannot assume that this is going to be sorted, really. So one thing we might want to try out first is to sort the array. All right, and then by frequency. Yeah. So we sort by highest number of elements possible, and then we simply return the number of k elements. All right, pretty simple, honestly, but there is an n log n. This is an n log n solution for sure because of the fact we would have to sort this whole thing. Another thing we could do is implement a count array and a heap. So we could use a heap because if we if if we simply get the count of the number of elements in the array, then we could just append each key to the heap as we move along. So we have an array in a heap, and let's say, oh, sorry about the noise here. There's a little bit of a thunderstorm going on, in case you haven't noticed. But we could add counts to our array. So let's get counts of each element. Okay, and then we simply add the count keys to the heap. So that would mean maybe heapifying this on your list here, and then use like the heap push and the heap pop commands here. And then our result array is empty. So this is what we're going to be returning here. Pop so pop k keys out of the heap and return the result. No results. All right. So yeah, another pretty good solution here. I won't say it's n log n, but rather n log k, just because like if you use a list to like use a heap on, operations do typically take O of n time complexity, just because of how complicated this could be. But that's just another solution to the attack here. I honestly don't know too much about these two solutions here, but one I do know about is using O of n time complexity. All right. So what we could do here is use an empty count array, and then we could declare an array of empty frequencies or arrays. We do this of size n, where n is the length of the array here. So why do we need these? These actually. So our count array is going to simply count what elements we have in our array, and then we're going to have this 2D array here, as shown here, that's going to represent the groupings of what elements have specific counts. All right, and then we'll loop through nums. And then what we do here is this is actually going to be a map here. Just because we want to store the frequency as the key and the elements as our values here. And then we would have count n, and for a specific number, it's going to be equal to 1 plus count dot. We use the maps get function. And then we'll loop through counts the items. So that's like each key value pair in our map here. What we do is take our array here. We take whatever is our count here. Then we append the element. Element list, because the values are going to be lists here. All right. Should be another thunder boom coming up in just a second. Just warning. There it goes. And then we're going to have our result array right here. All right. It's going to be empty, but we're going to append to this as we try to wrap this algorithm up. So what we're going to do is loop through. We're going to do another loop using index I. We're going to take a length of our frequency range for frequency array -1, so that we actually get the last element without causing an overtime error, all the way down to 0, and then because we don't need any elements with 0 counts, of course, and then we just need to decrement here. We're gonna I don't know how to spell. So yeah, we would have a for loop set up this way because again, we want to return the top k frequent elements. Our frequency array is going to be sorted here for us, so that the counts are going to be arranged from smallest to largest counts of elements. So we want to get the last elements first so that we can correctly return the top k frequent elements here. Right? And now we append. So now we got to do another loop here. So add elements at frequency I. And then we stop and return the result when the length of the result is k. All right, so this should work. Time complexity is going to be an O of n solution, just because we are going to be looping through every element in the array, basically. We have a few other for loops as well, but they're going to be a little less than that, actually. So we're going with worst case scenario here. And this is going to be an O of n space complexity as well, because we're going to have an empty count map here that in worst case would have n items here, because of the fact that there could be we could have an input array that has all distinct elements, and then our array of empty frequency arrays could also be is also already going to be declared a size n, as we're going to see in the code that I'm going to write in just a little bit. And so it's going to be O of n space complexity here, but much better runtime than using sort or heap here. We're actually using this special kind of sorting here, and that's actually called bucket list sorting. So we can basically take our elements and sort those in an array and sort them into buckets represent the counts of each element here, and that's what our map is going to perform. It's going to have these buckets of counts here. All right. So now let's try to write the code out for this. All right. So let's start off by declaring an empty set map. It's going to be a dictionary in Python. I'm not going to be using default dict today. We're going to have our frequency array. So it's going to be array. It's going to be a 2D array specifically. We're going to have multiple of them to start, but they're all going to be empty. We're going to have as many we're going to have the size be of arrays, the number of arrays in this array as the number of elements in nums, just in case there are going to be all distinct elements in our input array. All right, and then we loop through the number solution. So this is actually not good. It actually needs to be so because it needs to be an array and be a number here. So count n equals 1 plus count.get n is 0. So we loop through the nums array and we get the count of each element here. And this count.get function is useful because it's going to append to whatever count that we had before we write to this element. And if we have this, we're adding a new element to the map. It's simply just going to initialize to 0, and then we're going to be adding 1 to this. All right. So that sets up our hash map here, and then we want to loop through the items in our hash map. Then we're going to add our elements for specific counts in this frequency array here. All right. So now we have our final results array. That's what we're going to be returning here. So we're going to loop through our frequency array, starting at the last element. Go down to 0 because there's no use in returning elements with 0 element. This is returning the 0 group. We decrement our index by -1 each time, so that we can only return the top elements, not the bottom elements. We're going to do one last for loop here. We're going to look, but this is basically just going to loop through the elements in our frequency group here. And then we append our element to our results array. And then we want to check to make sure that length of result is equal to k at all every time we run the step here. Because that is our signal that we have found the top k for equal elements. And we can simply return our array. All right. So, and let me just fix that real quickly. There we go. Let's submit this real quickly. All right, it looks like we got a passive function here. All right, so that basically explains our algorithm here for solving this problem. So this is actually a bit more of a complicated version of code of what I wrote in the run that I did of this problem. So here's one last Python solution. You can actually count the number the frequency of elements in an array by using the counter from the collections module. So if you use the counter in Python, actually, you can actually pretty quickly get the count of each element in the array just by using the counter constructor here, here, here. And then there's actually a built-in function that simply returns the k most common elements here. So if you know how to use the counter here in Python, it can save you a whole lot of time with trying to come up with a solution. I've not seen anything for Java or C++, unfortunately, so I figured that I would want to start build a counter from scratch here, just so that you can implement it yourself. Oh, so I provided this whole thing for better reference here, if that makes any sense. All right, but I think that's it for today. Thanks so much for watching, guys. Be sure to subscribe to my channel to stay tuned for the next video that I will be publishing hopefully soon. And again, I will always post the solutions in C++ or Java in the comments. So be sure to check those out if you do not use Python for your code. But that's it for today, guys. Thanks so much for watching. So long.